The European Satellite Agency and the Euclid Consortium are actively working to create the Visible to Near-Infrared Space Telescope known as Euclid. Moreover, a NASA official stated on October 17 that the European Satellite Agency has started exploring options and evaluating whether it will be possible to launch using the SpaceX Falcon 9 rocket carrying the Euclid Near-Infrared Space Telescope. So what's behind all these, and what exactly should you know about SpaceX launching Europe's next deep space telescope? Welcome to Smarter Tech for all the interesting technology news worldwide, and without further ado, let's get started! Firstly, this information was presented at a meeting of the Astrophysics Advisory Committee. After all domestic options fell through, Director Josef Aschbacher announced less than 3 days later that ESA would work with SpaceX to send the Euclid telescope and Hera on a mission to an asteroid close to Earth. But what exactly is this Euclid? It's a 1.2 m diameter silicon carbide mirror telescope made by Airbus that will feed two instruments, VIS and NISP, built by the Euclid Consortium. A high-quality panoramic visible imager, a near-infrared 3-filter photometer, and a slitless spectrograph. With these tools, physicists will look into the history of the universe's growth and its structure changes. They will do this by measuring how the effects of dark matter's gravitational lensing change the shapes of galaxies and how the three-dimensional distribution of structures can be figured out from the redshifts of galaxies and clusters of galaxies. The Falcon 9 rocket will send the satellite to the L2 Sun-Earth Lagrangian point where it will stay for 6 years. Euclid will look at 15,000 degrees of the sky, which is the darkest and doesn't have any light from our galaxy or solar system. The mission will also look at 3 Euclid deep fields that cover a total area of about 40 degrees. This will allow scientists to learn more about the high redshift universe. Before we continue, hold up. If you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic, interestingly, the survey comprises tens of petabytes of data and hundreds of thousands of images. Euclid will look at about 10 billion sources and more than 1 billion will be used for weak lensing. Several tens of millions of galaxy redshifts will also be measured and used for galaxy clustering. Scientists from the Euclid Consortium look at these data from a scientific point of view and try to figure out what they mean. When the ESA's Euclid spacecraft launches, more than its 1.2-meter telescope and 2 high-tech wide-field imaging instruments will be at stake. Together with measurements from 2 next-generation facilities, the Rubin Observatory and NASA's Nancy Grace Roman Space Telescope, Euclid will collect data during its 6-year mission in a heliocentric orbit about 1.5 million kilometers from Earth that will help cosmologists learn basic facts about the universe. In particular, the spacecraft will try to figure out everything about dark energy, the mysterious force speeding up the universe's expansion, and dark matter, the invisible stuff that holds galaxies and other cosmic structures together with its gravity. Einstein's general theory of relativity will also be put through a tough test by Euclid's research, which will be done on a very large intergalactic scale. There could be a chance that we will find out about groundbreaking new physics or even about the fate of the universe itself. Basically, Euclid's main goals are to measure how galaxies group together and make a precise 3D map of how dark matter and dark energy change over time. All of this will help scientists figure out how fast the universe is expanding and whether or not the amount of dark energy stays the same. Euclid will be able to measure the shapes of more than 2 billion galaxies and the distances of hundreds of millions of others with a level of accuracy that has never been seen before. It will do this by making observations in both visible and near-infrared wavelengths. In terms of quality, the photos will be better than anything that has been taken before. The visible wavelength instrument on Euclid will also measure how weak gravitational lensing distorts the way faraway galaxies look. When light from galaxies travel through warped space-time across stars, galaxies, black holes, and clumps of dark matter on its way to Earth, it can make galaxies look bigger, smaller, or stretched. This is similar to how things can look bigger, smaller, or stretched when seen through glass or water. By looking at this distortion, scientists can figure out the mass of the visible or dark matter in the way that is causing the light to bend and limit the effect of dark energy. In the early and middle 2010s, ESA and Arianespace started developing a rocket to replace its very successful and once competitive Ariane 5. At the same time, they disregarded SpaceX's vocal pursuit of inexpensive launches using reusable rockets. Ultimately, European stakeholders decided to create a fully expendable successor called Ariane 6 that modified the components of the successful Ariane 5 recipe. Ariane 6's launch debut has been delayed from 2020 to late 2023 at the earliest, despite taking the easy way out in 2014. Over the years, this has caused chaos for many commercial and institutional European payloads assigned to the rocket. Then, in February 2022, Russia invaded Ukraine for a second time without authorization, destabilizing the rest of Europe. OneWeb lost hundreds of millions of dollars because Russia broke a launch deal and held a group of satellites made in the US and owned by the UK hostages as part of the war and in response to strong criticism from Europe. They formally ended all collaborations with ESA and Arianespace in a double-down move. This ended the practice of Europeanized Soyuz launches and left other collaborative missions stranded or in limbo. Such a mission was Euclid. The tiny near-infrared space telescope's development started in the early 2010s, and as of 2013, it was estimated to cost more than 1 billion euros. At the time, it was planned to launch Euclid to the L2 Lagrange point of the Sun-Earth system as early as 2020 using a European Soyuz 2.1 rocket. The ESA briefly stated that it would launch Euclid on Ariane 6 in place of Soyuz after Russia's second invasion of Ukraine eliminated that option. According to the European Space Agency, in October 2022, the launch debut of Ariane 6 was postponed from its current aim of late 2022 to late 2023 or potentially early 2024. And given that a Russian rocket left Euclid orphaned, it wasn't a major shock when SpaceX took over Arianespace's launch of the telescope. However, the announcement that Hera would do the same at the same time was far more surprising. Hera was supposed to be one of the first things that an Ariane 64 rocket with the brand new Asterisk kick stage that Arianespace was making would launch. After the most recent delay of the two-stage variant, Hera would have been substantially more likely to miss its 17-day October 2024 window if it had continued with the first three-stage Ariane 6. If Hera missed that small window, there would be backup options in 2025 and 2026 due to the way orbits work. This would make the mission's cruise phase go from 2 years to more than 5 years. Nevertheless, the €290 million Hera mission's primary objective is to enter orbit around the asteroid Didymos, which is close to the Earth, and investigate a brand new impact crater on Didymos' moon, Dimorphos. This crater is new because NASA's DART spacecraft crashed into the asteroid moon last month to make it. SpaceX sent DART to Dimorphos on a Falcon 9 rocket, and now it will send Hera in the same way as soon as October 2024. The Euclid telescope will be sent into deep space by the Falcon 9 rocket. This could happen as early as the middle of 2023. The measurements made over the next 10 years could also help solve one of physics' mysteries. Researchers may be able to put tighter limits on the masses of neutrinos by looking at how galaxies and even bigger cosmic structures grow. These are fundamental particles that have no electric charge and don't interact much with ordinary matter. Every second, billions of these ghost-like particles pass through your body without having much of an effect. But on intergalactic scales, their huge numbers can impact how the universe has changed in the past and how it will change in the future. But do you think NASA will also look for Tesla to launch the upcoming Roman Space Telescope? And will the launch they are planning be successful? Comment down below. Also, please leave a like and subscribe. Don't forget to turn on the notification bell for more amazing videos. Goodbye!